Okay, I've started recording. The other thing to keep in mind is that I have a reasonable understanding of these contracts now, but I'm by no means an expert yet. So correct me if I say something wrong, but mostly I think I've got it.
Well, yeah, you're gonna know more than me, brother. So I appreciate it.
Okay, so I have some slides to start with. So I will just, essentially, just as you already know, Marlowe is a simple language for writing smart contracts on the Cardano blockchain. It's primarily a Haskell domain-specific language, which means that it's a small language which ends up being expressed as Haskell values, so that you can write a Haskell program to create one of these smart contract programs. It can also be manipulated in Blockly, and we'll be doing both, and I'll show you the kind of pros and cons of using the two tools. But we're mostly, at least in this lesson, going to be focusing on the Blockly side, so we can get the smart contract aspect
Awesome.
nailed down. I'll show you a little bit where Haskell helps with this stuff, but the goal, mostly we're going to be drawing the blocks. So a little bit about Marlowe that I've read up on. It's basically quite simple and limited in scope, which has advantages. Like, you can't really express any complex algorithms or anything like that, but that has the advantages that this can be completely analyzed, and like it guarantees that there are no crashes and no infinite loops in this, but that doesn't mean that we can't get it wrong. So it's still important to think carefully about all the cases and steps in your smart contract, which we are gonna kind of have a little taste of today. Whether to use Haskell or Blockly, I'm going to say that for learning and exploration, especially in the early stages, go with Blockly. But you'll find that once your smart contract kind of gets big and there's a lot of repetition, that's where you can start using Haskell, and that'll be, that'll help.
Yeah, I know it. I've played with Blocky and noticed that some of the things I built, all of a sudden, like certain sections would be going sideways forever. And
oh yeah. So Haskell can help you simplify this basically, right? So yeah, just keep that in mind. That's the like, there is no inherent power difference. Haskell isn't more powerful at it doesn't give you the ability to express a more powerful contract. Everything you can do in Blockly. It's just management of the complexity as the complexity gets large that we're really talking about. Okay, so for our first example, we're going to keep it real simple. We're going to basically write a valid contract that does nothing. So basically, what my intention for this lesson is to make simple contracts and then build up on those and add new features. The final being a model of what the fiber exchange or protocol is. So we'll start real simple. So we are on this, and key thing is I want to show you how you can switch between the simulation and this Haskell editor and this Blockly. So we'll start with Blockly, right? So we have this outer thing that just says what we need is a contract. So we can look into contracts, and there's a kind of whole lot. And what we're going to start off with is just a simple close contract, right? So you can, as I'm sure you've seen, you can slot these in and it tells you if this fits. Now this jigsaw puzzle thing actually corresponds to Haskell types, right? So the whole thing is, the top level thing has to be a contract, which means that whatever you put at this top level is one of these contracts, and conveniently they slot in like puzzles. If we try something else, like say, if we try put in some kind of action in there, you'll notice that it doesn't work. You can't, although yeah, the puzzle kind of matches, but it actually doesn't work. And that's because in the Haskell world, that this is not the type that this contract is expected to be. So you'll remember in the last lesson, we talked a little bit about values and types. This, if you can think about something is correctly typed if it fits like that. And
yeah, that's one of the things I like about Blockly is that if the pieces don't fit, the code doesn't work.
Yeah, that's what I like about Haskell too.
Yes. Yeah. Once you understand how to read it, absolutely.
Yeah, that's right. So, but I think this is a real useful way of working with it. So if we send to simulator, it just says close because that's a representation of that simple close contract, right? So you can see in the simulator here, there's actually, because the contract just immediately closes, there's nothing to do. So there's no valid inputs that anybody can put into the transaction, which is fine. The other thing to note is what close actually does. So close effectively ends the contract right here. And later when we're in more complex contracts, we're going to sometimes close in the middle of a contract. And what that does is it basically refunds everybody's account. So if your account in your contract has some amount of money, when the contract closes, you get it back. Cool. And what I'm going to do is just get that same close contract written out here too, because I think it's worth doing. So I'm going to delete some of the stuff that I've been playing with. And all I'm going to have is close. Right, so that's what the Haskell version looks like. There's this main method, which isn't too important, but basically all it does is print the contract. When I say print, I mean display on the screen, not literally print on a printer. And we've got a value called contract, which is of type contract, and its value is close. So if we compile that, that's our output, which is just what we had.
Gotcha.
In this simulation anyway. Okay, so yeah, three forms, right? Blockly, the simulation text one, and Haskell. They're all quite similar, and usually you can take what's in the simulation and paste into the Haskell directly, and we'll see that. Yeah. So that was the simplest possible example. There's nothing to demo because it does nothing. So let's make it a little bit more complex. Our example 2 is we're just going to send some money from the buyer to the seller. So again, we'll start this in Blockly. We can delete this close. So what I want to do is this time, again, we're talking about a contract and we're going to take a pay. So pay is the act of transferring money from one account to another. So I'm just going to put it in there. And then we've got to fill in all these various slots. So for Payee, it looks like we want to put in a Payee. And that's essentially, there are two options for Payee. You can either have an account with an account number or straight pay to a party. So I'm just going to say account number. Because I think most of the payments we want to actually handle are with accounts. So we can pay into account 1 with owner. So we're paying to the seller, so the owner should be the seller. So the owner is a party, and we'll take this role seller. Just briefly, when we're choosing these between these two parties, if you use a public key directly, that's talking about a specific party. So this contract is only written for that specific party. If you're talking about a role, then this contract can be applied to multiple parties. So for example, you and I can have a trade using this smart contract where I am the seller and you are the buyer. But then we can apply the same contract to somebody else at a later time where somebody else is the seller and somebody else is the buyer. So the role value is more general than the public key one, which is just to a specific public key. Yeah. Okay. So that's who's receiving the money, and we'll pay from account 0. Usually I just these just go up 0, 1, 2, 3, 4, 5, 6. And in programming, with few exceptions, counting starts at 0. So that's
why are you using 0 now lower than where you've used number 1?
Oh, it's physically, like, spatially lower, but to me,
because it's in the purple.
No.
So
I put that in there. It started out.
No, but what I'm saying, you say spatially lower, is because it's in the purple blocky, that number, that 0 is actually higher than the blue block in the code.
Yeah, I guess that's, you can think of it like that. But what I was going to say is, I guess I think, and again, I'm foreshadowing the next step that we're gonna get into. But basically, I think that the buyer has account 0 and seller has account 1. So I'm using it as such. You could just as easily do this backwards, right? So if you wanted 1 first, that would be completely fine.
I just know that some people like me will be looking at thinking, why is he now going lower or higher,
Okay, I've got Steve Aldrich waiting in the...
Oh, yeah, sorry, that's my classmate.
Okay, I'll admit him.
Thank you. This is co-host, possibly, of a possible food podcast that, that these are being recorded for.
Sure. Hi, Steve. Cool. So anyway, so I'm gonna go on. And we're paying from the buyer to the seller, right? So we're from account 0 to account 1. And like, you could just as easily choose 1 and 0 like that.
So there's no reason why numbers have to be higher and lower in certain positions.
No, it's not about amount. They just have to be, they're just identifiers. Think of them
just
as
an identifier.
numbers.
Thank you.
Yeah. Okay. And what we're going to do is we're going to fill in the currency. So the currency was a token. So we're just going to use ADA. You can play with other tokens and currencies as well, but for us, it's going to be ADA. And I'm just going to say 500 ADA. So the way you put in 500, it's a value. And if you just want to put in a fixed value, you use the constant term.
And if it went on this fixed value, when you say 500, would that be like a number that someone had inputted in the front end of this contract, or would that be always hard coded in this contract?
So in this case, it's hard coded. Okay. But I can show you how, if you're generating this contract through Haskell, you can have that as a variable number. If you've got a front end that generates this contract, say hopefully through Haskell, because that'll make things easier, then you can vary this. And like, I will show you that specific thing very shortly.
Cool.
Let's kind of finish the...
Yeah, thank you. I'm sorry.
Yeah. So cool. So we have paid the seller the amount of 500 ADA from the buyer. There's a kind of fatal flaw to this contract because the buyer doesn't actually have any amount in their account right now. Because remember, these accounts are only accounts that live during the duration of the contract. But we're going to get to that. And then the next thing you have to do in all of these things is continue as, which is what happens next, right? And in this case, we're just going to close. So we're just switching from one account to another and then closing. So if we send this to a simulator, this is kind of what the code looks like. And sorry, should be. And now if we Now there's a warning here. So the warning here says the contract makes a payment from account ID 1 before a deposit has been made. So that's a warning saying, you need a deposit before you can actually pay. However, before we do this, I want to actually show you what you would do in Haskell and how you'd make this amount variable. So I'm just going to copy this and paste it into the Haskell editor here. So this should literally compile after you paste it. And it does. So that's cool. That's now, if we wanted to make this a little bit more variable, for example, we can take a number as an input, and that's the amount that we're paying. Then we're going to change this. At the moment, it's just a value for a contract, but we can change it to a function. So it goes from an int to a contract. Remember that an int is a number, like a whole number. And then we can name the parameter amount, like that. And then we, instead of writing 500 here, we can say amount. And now the last thing we have to do is then, at the moment, we're just calling contract, but contract now needs that amount. So we'll say contract 500, like that. And if we compile that, okay, just a small, if you'll recall in the last lesson, I kind of briefly talked about the difference between an integer and an int. So this kind of confusing error message says that constant actually expects integer, not an int. So that's not a problem. We just change it to an integer here.
Okay.
And now we have it, right? So if we run this with 500, then we get this 500 contract. If we run it with 1000.
And that's how you would be able to then, make that,
make that
front-end contract. Someone could decide how much they were paying.
Correct. Yeah.
Cool.
Yeah. And this is where expressing this in Haskell becomes useful, because if you only had this, then you would kind of have to mess around with like text manipulation and trying to insert numbers, and it becomes very, very awkward very quickly. So this is where, like, the actual structure of the contract, Blockly is useful, but when you actually want to vary things or not repeat yourself or kind of things like that, then you go to Haskell. Cool. Anyway, so the problem here is that we have to respond to a deposit. So let's kind of do that. So I'm going to take this whole contract off and put it off to the side. And this time I'm going to use this when. So whenever we need to wait for something to happen in a contract, we use when. So what when takes is basically an action. So if you put an action in there, it'll fit, nothing else will fit. So that's the case. And basically, so we're waiting for some condition to happen, like some action to happen, and then we're going to do our contract. So I'm going to put our contract into the continue as here to start with. And the other thing we'll do is look at actions. And what do we have? Well, the obvious one that we're trying to solve is this deposit one. So we can put deposit in here. And again, so the deposit is by. We would expect it to be by the buyer. So one thing I've noticed that I found quite useful is you can duplicate these. You can just right click on the puzzle block and duplicate it. And then this amount is so I'll just duplicate these. So when the buyer deposit 500 into the buyer account. So they are going to deposit into, and we said the buyer had account 1 in this case, so we'll say into account 1. And the owner, well, for the owner, we'll just copy the buyer again. So the buyer is depositing into their own account originally, like that. And so, sorry, I made a mistake. I wasn't supposed to put that pay contract here, and I'll explain why in a second. But yeah, so when the deposit happens, then we continue as the pay, right? So one thing, this is kind of an unusual way of programming, which is that instead of writing like steps in a list, you know, do this first and then do this and then do this, what you do is you have a command or a value like a when, or a action like a deposit, and that kind of has a bunch of conditions and things, and then it has this continue as, which is what's called a continuation, which is what to do next, right? So instead of trying to put this pay after the deposit, what we actually do is it's part of the deposit, like it's the thing that the contract continues with when the deposit happens. Right, so we end up with this. Now I want to talk about this continue as and after slot. So, because that's the only thing left to remain. So basically, as I'm sure you know, Marlowe contracts have the concept of a timeout. So basically, if nothing happens after a certain amount of time, then a default contract can happen. So for example, here we can say if after 5 slots nothing happens, we continue as, we put another contract which is just close. Okay.
No decisions made. Close the contract.
Yeah, that's right. So if the buyer doesn't deposit within 5 slots, if the buyer doesn't deposit within 5 slots, then the contract automatically closes. Yeah.
In most of the times, though, in a contract like this, though, wouldn't they be depositing into like an escrow, or why would they deposit in there? Can you deposit in your own account?
You can. I guess this is very simple, right? So the whole thing is, all I wanted to do was have the buyer transfer from their own account to the seller. So by all means, they can deposit into someone else's account as well, like an escrow account. Gotcha. And in fact, it's kind of, I mean, we can make a third. Yeah, this is a good thing to do. So let's do it right now. So the buyer will actually transfer. Okay, so that's a little bit more complexity, but yeah. So the buyer instead can transfer into an account. We'll still call it number 1, but the owner can be escrow. And then in the second step, we can pay from the escrow to the seller, right? It's essentially the same thing, except now, if the contract was to close prior to this payment, the escrow would keep the money, not the buyer. So we're gonna spend some time.
So you would need to add a step that if it after 5 slots, if that hadn't happened, the money would be returned.
Yeah, that's what you do, and that's what we're gonna have as our final step in our Fiverr contract, because that's exactly what we want to do.
Cool.
But here for when, right? So in this case, we're talking about when a deposit happens. So if no deposit happens after slot 5, then we don't have to pay any money to anyone. We can just close, right? Because nothing has happened, no money has exchanged hands yet. So remember that this when is waiting for a deposit to happen. So this other thing is what to do if that condition doesn't happen.
Gotcha.
Yeah. So in this case, we can just close. We don't have to do any paying back. Cool. So let's send that to a simulator. So now you see the simulator smart enough to tell us, well, we can either make a deposit, or we can kind of wait, essentially. So let's wait a couple of slots just by clicking on it, and then we'll make that deposit. And if we actually look at the logs here, then what happened is in slot 2, 500 units of ADA were paid into roll escrow, and as roll buyer, and then the final thing that happened was that the contract paid 500 ADA to the seller. So that's essentially, these logs tell you all of the kind of top level actions like deposits and payments. So what's actually happened is, you notice also this, somewhat annoyingly, this simulation actually, we started with this, we sent it, let me just reset it. So this simulation kind of does the when, and then the deposit happened, right? So then it automatically does that, and it leaves you with what's left. So it actually like collapses this text. So don't expect this to save your text when you're testing. You're actually going to lose it. So
Gotcha.
the other test we should do is just run for 5 slots and make sure that nothing happens. So at the moment we've got nothing in the logs. So if we just go 1, 2, 3, 4, 5, closed, nothing happened.
And it closed because no one did anything.
Yeah, that's right.
Yep.
So that's that part here.
Yep.
The closed part happened. Okay, cool. So far so good. But if we go back to my slides, the next thing we have to do is, obviously at the moment, the payment just happens and the job may or may not be done. So the next thing we want to do is ask the seller, is the job done? And the other thing I want to say is, if they don't act, then we should assume that the job is not done and not pay them.
Yes.
So we'll take off this pay because that's not, and the next thing we want to do is we want to look at this. We want to actually have the seller in this case make a choice. So you can't just fit that in there. So what you're going to need is another when, right? So when the deposit happens, and then we have another when inside there. And so what we're going to do is we have a choice, and that's just an identifier that's useful for us. So I'll call it job done. It can be anything. Mm-hmm. And the owner in this case is going to be the seller. Because it's the seller that tells us, yep, the job is done, right?
Yep.
Choice bounds. That'll just bounds. Now, when deciding what goes into these slots, I think like they've done quite a good job at naming the things. So like if it says bounds, then it's probably going to be a bounds. For currency, it's a little bit confusing. It's going to be a token. For owner or something like that, it's going to be a party. So it takes a little bit of getting used to. And the other thing that I'll briefly mention is that when you're working in Haskell, the types of the various values are kind of called the same thing as they are here. So here it says contracts, which means that the type of a contract is contract. So you just drop the S from the end. So you have contract, action, value, not 100% sure about Payee. I'm going to guess Payee as well, party, and so on.
Gotcha.
And we'll get into that. Anyway, so what we're having is we're having the seller make a choice whether the job is done, and I'm going to make that between 0 and 1, right? So that meaning, obviously, they basically choose a number, and it's entirely your own convention what those numbers mean. So you can have 1 and 2 if you like, but
And now all that is, you know, for example, 0 would mean the job isn't done. 1 means the job is done.
Yeah, and because it's a very strong programming convention that 0 means no and 1 means yes, if it's a yes/no choice, I would say between 0 and 1.
Yep, that makes sense.
Yeah. So they make a choice of between 0 and 1. And now what we have to do is, based on that choice, we have to decide whether to pay the payee. Or remember, we're still building up to this slowly, so we're still not confirming. We're just at this stage, we're just trusting the seller to tell us the truth. So if the seller says job done, then we pay them, and if they say job not done, then we don't pay them. So what we're going to do is we're going to add another contract. And this one is called an if. So an if is basically where you have to make some kind of decision. The difference between a when and an if, because I mean, at least I found that a little bit confusing when looking into this stuff, is when reacts to actions. So these are like external events that happen. Whereas if is something that makes a decision based on values that are already in the system. So if you're choosing between account balances or, for example, choices, then it's an if. If you're waiting for some action to happen, like a deposit, if you're waiting for a deposit or something like that to happen, then it's going to be a when. Anyway, so
thank you. That is very helpful.
Yeah, it was a little bit of like when staring at the code, it's a little bit confusing, but again, this will take you a long way, because if you try you can put an if there because it's a contract and this expects a contract, whereas the other thing, if you try to do a when, oh no, you actually can do a when as well, so it's not going to help you. But if is the one you want here, because you're deciding between values that are already in the system rather than waiting for something
external choices.
Yeah. And the main thing also you'll see is that, which can be another hint to you, is if doesn't have a timeout, right? So you just decide on the spot what the case is, whereas when does have a timeout, which is this after slot. So that's another way of, like, we're not waiting for this observation to be true. We're just checking if it is true right now. Anyway, so let's go into observations. So we basically want to check if the choice made is equal to 1, right? That's when we pay. So I look at all these observations, and this one is the one we want. If the value is equal to another value. So the value that we're looking at is the choice made. So if we look at values, it's choice. So the choice name is job done. That's the choice. So that goes in there. And the role was the seller as well. So we can just duplicate that and it goes in there. And it's got to be equal to another value. So because this is just, we know that this value is 1, then we can say value is constant. And conveniently, it starts with 1 there. Complete coincidence.
So this piece of the puzzle means that this is relating to when they choose 1?
Yeah, okay. That's right. So they have, at this stage, because this choice has already happened, they have either chosen 1 or 0.
Gotcha.
And yeah, so we're saying if the value of that choice is equal to 1, then we can do this whole payment.
Gotcha.
Right?
That makes good sense.
Yeah. Now we've got to.
And now they have to have the. Oh, I think you're right in right that direction.
Yeah. So that's it's that direction. So if they chose 1, then they get paid. Now if they chose 0, then they don't get paid. So the money should be refunded. So what I'm going to do is duplicate this pay block and then change it a bit. So this time we pay in this case, actually, let's just pay the buyer back. So party buyer. That same constant amount. You see how that's repeated all over the place, and that's the downside of Blockly.
But for people who don't know how to code, this is an easy way for you able to build it. It can get a little bit unwieldy, but yes.
And it's actually quite nice, kind of, because you can explore things and stick them together. So I think it's actually really well done. I'm usually extremely skeptical of like visual programming tools, but I have only good things to say about this. So yeah. Anyway, cool. In the else case, we are paying the buyer the full amount from the escrow owner, from the escrow account. So, and that's paying the buyer directly. It's not messing around with accounts or anything like that. So as far as I know, you have to pay from accounts, but you can pay directly to parties or to their accounts. It's really equivalent. For example, if we instead had a buyer account, we could pay into that, and then when the contract closed, they would get the money. It's equivalent, but this immediately pays them.
Gotcha.
Okay, so let's simulate this. Let me just reset this. Cool, so you see it's a bit unwieldy now. Oh, we're missing something. So let's just go back and fix what we're missing. When you see one of these question mark something, that's called a hole. And these holes mean something's incomplete. So let's just have a look. So the final thing we have to do, right, is when this job done choice happens, otherwise that's we're asking the seller if the job is done. We have to also decide
how long
what
we wait for
when
them.
They don't answer, right?
Yep.
And I think what we're going to do in the case that they don't answer, we're going to treat it as the same as their answer 0. So if they don't respond with the job done, that means the job is not done. So I don't know. Slots are 20 seconds. And I've written like a little Haskell function that can translate days to days to slots, so you can go 3 days and that gives you like that many slots. But nice. I don't think that's actually useful when you're playing in the simulator, because then you'll have to simulate 12,000 clicks.
Yeah, you gotta click that thing ahead that many times.
Yeah, so you can do that, but for now we're not going to. We're just going to
for simulation low numbers, but for real life they're going to be much longer than that in most cases.
Yeah. Okay, so I'm going to say 15 here. So basically we've waited 5 slots for the buyer to deposit. And then if we say 15 slots here for the seller to answer yes or no, that means they've got 10 slots. So remember, this isn't how much time they've got. This is which slot this should execute as. So you kind of got to work out the range, I guess. So yeah, the buyer had 5 slots, and then this is going to time out after 15 slot. Sorry, on to slot 15. So that gives them 10.
Gotcha.
Yeah, but it's like it's a little bit of a, and what I did just now was I copied the payback code and put it back into this case. So yeah, now we've got basically buyer has some time to say if they did it. If they don't respond, then everything gets paid back. So let's try that. You know, live coding like this always presents the danger of bugs, but we'll see how we go. Yeah, so we'll deposit immediately, and then the seller can choose a job done. So first of all, I'm just gonna simulate the time passing so that they don't make a choice. I think it should be up to 15. So yeah, you see, if the seller didn't make the choice, then the buyer got their 500 ADA back.
Yep.
So let's reset, and this time we'll deposit, and we'll choose a value 0, saying job not done. Oh, sorry, yeah, we do that, and again, buyer got their 500 back.
Yep.
We'll reset, and now the interesting case, like the positive case. I always like to test the negative cases, maybe because I'm a pessimist, I don't know. But like, so here, this time the seller got the payment because they said 1. Okay, so that's already getting a little bit of complexity, but it's still basically not sufficient because it completely trusts the seller on what they say.
Yeah.
So the next issue, the next thing we're going to fix is have the buyer also confirm that the job is done. And this time it's a little bit different, right? When the seller confirmed that the job is done, we had them, if they don't act, we assume that it's not done. Here it's kind of the opposite. Like, if the buyer doesn't complain within a time period, then we are assuming that the job is done, all is good.
Yep.
Yeah, it's slightly backwards. So again, the main, can I zoom out a little bit here? Can you still see this?
Yeah. Yep.
Cool. So I'm gonna wait, not the else. That's the refund. I'm gonna take this part off and go deeper. So what we want to do then is, once the seller has made a choice, we also want the buyer to make a choice, but whether the job is done. So it's a contract, and it's what am I doing?
It's a win, right?
Oh, it's an action. Sorry. Yes. So in this case, oh yeah, it's a when and then a choice. Sorry, I just had a momentary blank.
It's the only reason I knew that for sure is because you explained the difference between
perfect.
the ifs and the wins.
Cool. Yeah. So we got another when, and this time we're going to have a choice name again, and the choice owner is going to be the buyer this time. And this name can be job done again. So these, it's the same identifier, but the owner is different, so that's fine.
Okay.
I just personally, obviously, I haven't written a lot of these, but I think when you're trying to get two people to agree on the same thing, I think naming it the same thing and having different roles is quite a good way of doing it. You could make it more explicit and have this one, seller job done, buyer job done. That would be fine too. But, so we'll duplicate this. We'll make it the same range. Cool. And now we have to basically, again, make a decision. So we have to make a decision whether the buyer and the seller agree that the job is done, and only then do we pay. So that's going to be an if. And this time it's going to be a value, and it's going to be, it's going to be an observation. And it's going to compare two values again. But this time, instead of just comparing it to constant 1, we're going to compare the two cases, right? So we're going to have the value, we're going to have one choice, and we're going to compare it to the other choice. So they have the same name, job done and job done. And this time, one is by the buyer and one is by the seller. So we'll duplicate this, and we'll duplicate it again and just write seller. Right, so that's our decision here. So if the buyer job done choice is equal to the seller job done choice, then we pay.
Yep, makes sense.
Else we refund, right? So I'll just copy this refund. Yeah, this copy paste ends up being horrible. And what I'm going to do when we've kind of finished this contract is do a little bit of refactoring where I put this refund value into one variable and then I use it around the place rather than repeating it all the time. But for now, we'll just do the copy paste thing because I want to kind of get to the end of the contract. And we still have a couple more steps. Okay, so where we're at now is, yeah, if the buyer and seller agree, in other words, their choice is the same, then we pay the seller. Otherwise, if they don't agree, then we pay the buyer back and we close. Now, the only other thing is we want to have a timeout for the buyer to respond. So that's for that job done choice.
So the seller says, yes, so your work is done, and the buyer doesn't respond.
Yeah. So in this case, we actually want to pay the seller. So we'll say, I don't know, slot 25. That gives the buyer 10 slots to respond. Obviously, these numbers are going to be a lot bigger because we're talking about people doing things. But in this case, we actually copy this one, which is we're paying the seller. So there's kind of, it's the opposite to the other one. Basically, if not responding should usually mean that the decision is in the other person's favor, in my opinion.
Yes.
And this is obvious, like this is kind of obvious, but at the same time, it's important to say, like, this is based on the rules that we decide, right? So yeah, there isn't a right and wrong answer for this. It's whatever we decide. But I think in this case, everybody would agree. Okay, so let's test that. Reset simulation. Cool. So this time, let's do the happy case first. So seller says job done, yes. Buyer says job done, yes. And seller got paid.
Boom shakalaka.
Yeah. Now let's say yes and no. So seller says yes. Buyer says no. Buyer got refunded.
Nice.
Yeah. So where are we at now? Well, now we've got a kind of decent system, except now, before we were trusting the seller too much. Now we are actually trusting the buyer too much because obviously in the case where this is a surefire way for the buyer to get free work, right? They just say
yeah,
no.
the seller could deliver and then say no, and the smart contract gives him his money back.
Yeah. So this is where we need a third party to decide in this case. So what we're going to do is go back to the Blockly. And so the bit that we are changing is, let me find it. So If the choices agree, then we're good. But if they don't agree, then we need then instead of just automatically processing this refund, we need to get a third choice from a third party. So what we're going to do is add another when. And let's handle the timeout first. So our last timeout was 25, so we'll make this one 35. And so in the case where the third party doesn't respond, I don't really know what to do in this case, right? This is one of those.
Oh, if the escrow person doesn't chime in.
Yeah, basically. So we, the seller says the work is done, the buyer says the work is not done, and usually, in this case, Fiverr will go to the buyer or to the seller and tell them prove to us that the job is done. So it's something that happens behind the scenes, but ultimately they have to make the choice. So look, this is completely arbitrary because this is like a terrible case, but if the escrow, i.e. Fiverr, doesn't respond, then we're just going to refund. If you don't like that, we can pay.
Yeah, the person could have a choice in how they design their contract.
Yeah, that's right. So in this case, we're deciding we're going to refund in the case that the buyer doesn't respond. But actually, let's give them a lot of time because it's really important that they respond. Otherwise, this whole thing doesn't work. So 45. Yeah, 45 clicks is not too much. Okay. And now, so what we need is another choice. So it's action, choice. And in this case, again, because we're talking about the same value, we'll call it job done again.
Yeah, I like that.
Yeah. If we're talking about something else, then we'll call it something else. But and the role in this case will be like escrow. So escrow will actually decide. The values will be the same as before. And we can continue with an if, right? So again, we've had them make the choice. Now we continue with an if. So this time, we want to choose if the escrow agrees with the buyer. Sorry, if the escrow agrees with the seller, then we pay the seller. If the escrow disagrees with the seller, then we refund the buyer. So I'm just going to duplicate this because it's going to be similar. So this time we've got the seller and the escrow. So yeah, this is deciding whether the escrow and the seller agree. If the escrow agrees with the seller, then we will pay the seller. So this is the same as the buyer agreeing with the seller. So we'll just duplicate that and put that there. Otherwise, we will refund. So that's refunding the buyer there.
Nice. One of the things too that while you're, when I was playing around on Blockly, I did not find any way to be able to like export or save anything I did. Will you be able to like copy and paste the code of this contract afterwards so I could paste it in the playground Blockly and play with it?
I'll show you how to do that immediately because I think it's important. So this contract is kind of done. So what we're going to do is send it to simulator. We just have to reset the simulator. So send that to simulator. So this is your code, right? I'll I'll copy it now because we don't want to lose it. Come on, scroll. Don't tell me you can't scroll. You kind of can. Oh yeah, there we go, cool. Okay, so I'll just copy all of that. I'll put it into a file just so it's safe. Cool.
Thank you.
I've saved it, so we have it. So the way to get that into Blockly is you can just send it there.
Yep, thank you.
So that gets it back. So let's test this. So again, we deposit, and seller says, yes, job is done. Buyer says, no, it's not. And at that point, it's up to the escrow to verify that the job is done. They might take some time, but eventually they say, yes, the job is done.
And the seller gets his money, right?
The seller gets his money, so you can see
Nice.
that here. And if we reset and do the other case, so seller says yes, buyer says no. Notice we don't have to check whether the seller says no and buyer says yes, because that was kind of handled at the beginning by checking whether the seller's choice is 1. If the seller admits 0, then we're all done immediately.
Yeah, we don't have any of these choices. Yep.
Anyway, so buyer says no, then escrow also says no. And in this case, the contract paid 500 units to the buyer.
Nice. Very cool, dude. That was so helped me understand this so much better.
I hope that helps. Yeah, you're just kind of doing step by step, you know. Just one thing before we finish is I want to just, I'm not going to completely tidy this thing up in Haskell because we don't have time, but I'm just going to tidy up a couple of pieces just to show you how using Haskell instead is useful.
Yeah, how Blocky maybe bloats the code some.
Yeah, that's right. So all I'm going to do is I'm going to do what's called refactoring. Refactoring is kind of the act of removing duplication. So if you've got something duplicated, you give it a name, and then you can, you know, use it in multiple places. So what I'm going to do is, to start with, I'm going to just paste this into Haskell. So I'm just going to delete what we had before. And yeah, I'm removing that parameter because you've seen how we can do it.
Yeah.
So contract equals, and I'm going to paste that whole thing that we had. Right, and believe it or not, this is Haskell. So like that simulation code that should work and compile just like that. I hope we'll fix errors if there are any. Yeah, cool. So that just produces the same output that we gave it. That's not surprising. But now, one thing that's quite annoying, right, is, you know, obviously reading this is, even in my opinion, more difficult than reading the Blockly.
Yeah, it's kind of very fractional.
Yeah. So what we're going to do is I'll find the two pays, right? So here we've got a pay from escrow to seller. So I'm going to cut that out, and I'm just going to call it payment. And then in here, we're going to make a new value. And I'm just going to paste what we had before. And we don't need these brackets just because.
Oh, I love it. It's kind of like preloaded modules at the beginning of your contract.
Yeah, that's right. So now, anywhere where we're paying the seller, because there were a few places.
I think it was.
Oh, there was one here. I think it was this one here. So payment. I'm just going to search for seller in this thing and replace the relative. That's a choice. So not that one, not that one, not that one. This one as well. So payment. Right, so that's tidied things up a little bit. We've got rid of a little bit like that. I'll just slightly tidy this up as well because you don't need so many.
And so I'm sure you're getting there, but in the other case, then you would maybe name one like refund,
Yeah.
and then go through and make the buyer's refund another module at the top.
And I will do that just to get to another because there's actually more duplication that we can fix. So I know it's a little bit of a busy work, but I'll just make that nice and
it's enlightening. I appreciate it.
Yeah, so we'll do payment. We'll do also refund, right? So payment, refund equals. In Haskell, there's this thing called undefined, which basically lets it compile, but it's crashed. So I'm just putting undefined until I find it. So this time we're paying the buyer, right? Buyer. And again, it's this payment, right? So we'll call that the refund. Right, you see how it's getting shorter.
Yeah.
So that can go there. We'll just get rid of some of these brackets. In the interest of time, I'm not going to tidy this up, but we could tidy it up into one line like that.
But I see what you're doing for sure.
Yeah. Let me just quickly find the other spots where we're paying the buyer and replacing it with refund. Right, it gets shorter quite quickly. And let's try compile this, make sure we don't have any errors. No, we have errors. Well, what's the problem? Could not match expected type. Okay, line 10, column 16. Oh, payment has to, payment is a contract, not a, what now? Account ID, what have I done?
Well, our motto is just like Bob Ross. We don't make mistakes, just happy little accidents.
Okay, unfortunately in programming, you have to fix the happy little accidents.
But at least one of the things I've learned, those happy little accidents are easier to find or quicker to find using Haskell than a lot of other programming languages.
Sure, because like a lot of other programming languages won't give you these errors, and you'll deploy this into production and it'll be running in your blockchain and crashing there, which is much worse, right? This is, I'm going to spend another 10 seconds on this, and otherwise, what have we done? Okay, I'm going to take us back a bit. Because it's this. So pay is a contract. Compile. Account ID is applied to too few arguments. Okay, just let me quickly check in the documentation. Account ID takes a payee, a token, a value, and a contract. Okay, payee, token, value, contract. I feel like, okay, sorry about this.
No worries.
This is the cost of live coding. Okay, I'm just gonna start again here. and refactor out one, like, because it's not convincing if I just tell you that you can do it, but it actually doesn't work. So let me just, I'm not going to go through and fix it everywhere, but I'll get the payment going again. So payment is contract. And what I'll do, I'm 80% sure that I just mismatched brackets.
Yeah, there's a lot going on in there. All it takes is one little extra or one not enough characters.
Yeah. Okay. So I think if we do this, this should be good. Compile. Yeah. So that worked. Okay. So now we can.
So even the novice, though, could go from Blockly to this Haskell editor,
Yeah.
and copy and paste these out, and not really try to reduce maybe the spacing in between them, up at the top when in the modules.
That's right.
But they could modulize their whole contract.
Yeah, that's right. So see, I've done it just now, and this time it compiles. I honestly couldn't tell you what went wrong before. But yeah, and then we got paying seller again. Here, I think it might have gone, so that can be payment, right? So we've modularized it because we've got two, yeah, and that's there.
Yeah, that's awesome.
I think, I think we were missing a bracket, which is cool. Let's compile. Yeah. So that's working, and we can send to simulator, and you can see the same thing, that we still got the same program. Choose value, job done. So I got paid.
Another awesome lesson.
Cool. I hope that was helpful.
Very.
Yeah. Yeah, I guess I'm gonna stop recording.